How come I can't hear you? Hello? Oh,
Hi, Sandeep.
I can hear you, Rahul. How are you doing? Hey, Sumashri.
Yeah, good. But yeah, busy day. Like my son birthday was yesterday. Yeah,
How
but
old
other
is he
than
now?
good, he's 5. He's the youngest one.
I see.
Yeah. Um, my daughter is 13. So,
I see.
yeah, in gap between two kids.
I see.
Yeah.
Hi Sandeep, good evening.
Hey, Ranbir, how are you?
Good sir, good.
Okay,
No,
now,
you're not celebrating Ganesh Chaturthi?
oh, I never celebrated Ganesh Chaturthi. As such, I just was part of the events.
Okay,
That's all.
okay. No, so we
Oh,
thought that you're going to give us off today.
Oh, you want to take off today?
I think mostly people will celebrate for sure.
Oh, okay. Okay.
wasn't that yesterday? Like my wife do that. She established Ganesh at home yesterday. I don't think so. It's today. I don't know.
Yeah, in case you want to have the discussion, open discussion, okay, and I think this that's needed.
Yeah, only 5 people today though, Sandeep.
What happened to everyone?
I don't know.
I'm guessing that people will join or something.
Yeah, maybe.
Or
It will-
is it
it will-
showing like can't join or something? Okay. Can you drop a message on WhatsApp group? Okay. Now my phone is has gone into D&D. Hmm. Okay. So let's start. Anyway, we can do this if right people are not joining. We can go back also if you have questions or if you're not confident about a topic or you feel that there is a lot of haziness in a certain thing, we can talk about that.
Sandeep, my concern there is now I understand the topics, but I do have some hidden fear when I'm writing the code. Actually, it's just not going away. So
Okay.
every time I try, I mean, first of all, I'm in that like in work, I don't have the opportunity to write the code. Actually, I look after infrastructure teams.
Okay.
Um, So I normally don't have the opportunity to write code there. So when
Okay.
I'm like practicing data structure or any other concept you are teaching it up, I generally don't feel confident that I can do it straight away. I can somehow able to manage it to do it whatever I want to do, but it's still some fear is in my heart actually when I'm putting my hands on keyboard to write code.
Like
I
the
don't
way,
know.
all
Yeah.
right. So it's like I was telling my wife that when I want to write my book, right, it is pending for like 4 years now, 4 or 5 years. Okay. And I feel this same lack of confidence the way right now you are saying about code. Okay. But though I know that okay, I can do it, I can frame the logic and I can frame the it's just that when I start writing, I don't feel confident. Okay. The simple thing is that right there stays fear is true when you are speaking. Okay. But that stage fear should not be there if you're talking to compiler. Okay. And I think because see, stage fear is real, it's difficult. Okay. A better thing is, how should I say, take up a small problem, the way we
Okay.
had been talking. Take a small problem at a time, one at a time. Okay. And try solving those. And easier thing would be that there's an echo. I don't know why it's
Rahul, it's only Rahul side. Rahul, I
Okay.
think
Okay.
you put some, on
okay.
speaker.
Okay.
I'll put me mute.
Okay. Okay. So I would say this, I would suggest this way. Take up small problems and do them slowly, one at a time. And the more you this, okay, do this, Rahul. Got a better idea for you and for all of you. Okay. Use Pygame and build a game with your son or somebody. Okay. Just follow the tutorial and build a game using Pygame with your son or your daughter or your nephew. And that way, basically, you will soon become very confident in framing the logic. Okay. That could be, mhm. Go ahead. Go ahead.
No, nothing. I'm good. Like, yeah.
Okay. So yeah, that is another thing that I'm observing, that when I'm say all you need is that looking forwardness to coding. Okay. So it's like a very important thing to know that so I saw this with me, that when I was not married and I was having a date in the evening to go out. Okay. No matter how much work I had in the day, I would be very active and I will be looking forward to it. Okay. No matter how bad day I had and so on, still I would be very active. I will not feel tired and right. And I'll just be, and the reason was because I was looking forward to it, right? Similarly, when you're looking forward to, designing that game, coding it up, and sitting with your kid or nephew or a friend, right? That looking forwardness or that, that self-interest will, um, basically, that self-interest need to be there. You need to how should I say? You need to construct that self-interest. Okay. And once you have that self-interest, right, days, hours, sorry, the minutes, hours, days will not feel burden. And the more you will write code, the more you will subconsciously improve. Okay. So you find your ways to code more. Okay. And the things that are stopping you, right? Things like there are people in your life, and like I have seen a lot, that who would basically criticize very quickly. Okay. So I avoid such people very, very often who criticize a lot. They feel like they feel that they're doing right thing by criticizing. They're giving feedback, but that's not how the human brain works. We don't work on the negative feedback. We work on positive feedback. Okay, I have not seen a single person in my life who improves the negative feedback. Okay, so start working that way. So figure out that joy. Figure out like eliminate that pain or negative things for people, and then focus on just doing it more. That's all. Doing it more. Okay. And there's no other way. There's no other way. The only thing that I want to do and I can do is not build a fear in people about coding. Okay. I saw that those in my career, there were two kind of people. One who studied from Kanitkar, let us see, okay. Then Then there were people who studied from Kernighan and Ritchie. Okay, two kind of people. Those who studied from Kernighan and Ritchie, they saw that such a complex thing can be done in 4 lines. Okay, so they had this, a lot of more interest. Those who studied from, let us see, they saw, oh, there are so, because in Kanetkar, he would write like 10 pages of code for a small thing. Okay. And the conciseness was not, so you subconsciously develop this fear, oh man, I have to type so much. Okay. And use a programming language which is concise. Don't use Java or another thing. I remember when I was coding in Java, oh man, I lost my interest in coding. Can you believe? Okay. I'm like, right? I did not go home in second year because I liked coding and I wanted to code in college. Okay. And when I started coding in Java, I lost that, interest in coding. And then I discovered Python, and then I have not gone back to Java. Okay. Though I can code, like I have written like a dire of a programming language compiler in Java, and I have written like a class loader and like a server in Java, but I hated it. Okay. So yeah. So I think the more joy you create, instead of making it look like a duty, job, or a right thing to do, make it like fun thing to do. That's a message to all, and I think that's a secret that is there. And the more you start getting feedback, and that cycle starts, right? So when I was not getting feedback on exercise, like I was not seeing any success, it never gave me, joy. But when I started seeing that success, I started doing it, and that's how it is. So as you start seeing small successes and you start celebrating those small success, like small wins, you basically you will do pretty good. I think that's something that I want everybody to know, that it's a art of managing yourself, art of managing yourself. And learning is hard. The brain wants to stay happy and stay in a zone where it doesn't have to think. Okay. And it doesn't want to do anything, well, right? It's difficult. So right, and you yeah, so I think that's where you got to figure out what works with you. How do you force yourself into a situation where you have to do it? Okay. I hate it. I did not like the public speaking. I'll tell you this. In college time, I was very afraid of public speaking. Okay. And my brain rejected it every time when I got the opportunity. Okay. So what I did was I forced myself into this. Okay. I knew that this is the right thing to do. And in first year, I just fought election. Okay. I just stood up and said, okay, I'm fighting election. My brain was telling me, dude, withdraw. Why are you wasting? Why you'll have to talk in public and you have to, right? So one part of the brain was like dragging me back, saying, no, don't do this. It's waste of time. There is like so many things. Other part of brain was telling that, right, there is no harm, just do it. Okay. Nobody is going to shoot you. So I fought election, won, spoke in public similarly. So I think those are the things. And I think that was a very big deal. I mean, that's what differentiates me from the other people. That one is that I push myself out of comfort zone, right? So yeah, so I think like coming to Canada was one such example. Oh, man. I'm thinking that I'll live in London for some time. Uh,
Same here, Sandeep. I landed in Australia with $50 in my pocket. But yeah, I mean, yeah, I came here in job, but like I don't have cash when I move in here. I need to
wow.
stay my,
You were
arrange my
single that
stuff.
time?
No, with wife and one kid. but they come after 4 months.
Oh, okay.
Yeah, yeah.
Okay.
And my job is in one of the smallest cities in Australia, first job, and I got it like through LinkedIn. It was new in 2012. Like I was in Singapore, someone told me that you can apply a job there. I mean, internationally. So I start filling the jobs to Australia and New Zealand blindly. So I end up getting a job here. So I landed here, and the weather was horrible, like 45 degree. You feel like you are in middle of Africa actually, and the city
Oh,
was full of crocodile and all other reptiles, snakes, whatever you want to see it, you were able to see it. I thought, like, initially I thought I made a bad call moving to Australia, but then it worked out in our favor actually.
I
Like
see.
in 4 months, yeah, I got a job in Cognizant. um, they hired me as infrastructure manager there, and I then landed up moving to Sydney actually, and since then I'm here actually.
I see.
Yeah.
Nice, nice. Good, good, good. All right.
Yeah. Now
Uh,
we got enough people here, I guess. So we can
yeah,
start.
yeah, yeah. We're just waiting for everybody to join. Okay, before I start, is there any doubt in what we did yesterday? Okay, we did something that I always wanted to do, that we should do the teach NumPy by the way of real big example. And the great part about it is that we did it using NumPy. Okay. And the most wonderful part is that algorithm you had already studied earlier. Okay. So we are doing so well on things. And I think this is the perfect way of learning. That first we studied Python, we studied maths, then we moved on to coding gradient descent. Then we moved on to applying NumPy on gradient descent. So we are just going like stepwise, first up, then horizontal, first up, horizontal. So we are traversing like 2 3 dimensions. Like stairs are 2 dimension, right? And but we are traversing in 3 dimensional staircase. That's how I see it. Okay, and basically maths, coding, machine learning, and these libraries that are coming on the way. Okay, so I think probably if I have to, formalize my course, this would be the right structure to do it. Okay, this would be the right structure to do it. And I think this is probably the best way to learn, in the sense that we are just, beginning and the end at the same time. Okay. Like the way people usually do is they would start with, okay, finish Python, finish Python, finish Python, finish maths, finish, studying this library, that library, studying that library, then start memorizing the code for creating the end-to-end project, or applying machine learning. And then last, in the end, you will get to touch gradient descent. And I don't think even Aurelian Geron's book touches upon coding up your own gradient descent. It has a supplementary chapter on that. Okay, I checked it last time. So it has a supplementary chapter. It doesn't touch the how to code up the gradient descent. Okay, but I realized that it doesn't make sense. It honestly doesn't make sense to not teach that code algorithm that is there for everything. Okay, everything else, it's is very. So I think what we are doing is we basically just kind of doing a breakthrough in the entire of machine learning. Probably few years down the line, people would be teaching the machine learning this way. Okay, and I think my only request would be that as we go ahead, um, you know, even if you missed everything till yesterday, okay, till yesterday, even if you have missed all the classes, still ask questions, ask, and stop me saying, hey, I'm not clear what you're talking about. Can you just walk me through again? Okay, let's start.
Sandeep, I have one question. Um, so this whatever gradient descent that we were coding, it was only for the linear. I heard that the gradient descent works for almost all the like polynomials or quadratic equations or like big polynomials.
Yeah.
It okay. So even whichever curve, the gradient descent will work, right?
Yeah.
Okay.
You remember that formula that we did, that we added more features. X square feature, X cube feature, X to the power 4 feature. We
Yes.
added that. We had the data X and we added one column, X square, X cube, X to the power 4. Like I'll tell you. So how would you handle the multinomial, right? Let's say your data is really complex. You don't know. Okay. So I'll show you. So
Currently, we are assuming that it will be linear and we are trying to code in the linear.
So let's say secretively your data. Okay, so the way it happens is, let's say you have X data, right? And it is X cube with the Y equal to X cube times something. Okay. So, and you have X only. Now you don't know what it is. Okay. You don't know whether it's X square, X cube, or X to the power 4 or something. So what you'll do is you got one X column, right? In the data, you've only got one column. What you do, add one more feature with the X square values, and then one more feature, X cube values, one more feature, X to the power 4 values. So we call them polynomial features. So we basically add features, right? Now we do the linear regression on this. Okay, got it. So yeah, okay. Let me just show you. What do I mean? So imagine this. Okay, I think we could just take this. This is a very important thing. It took me a while to figure this out. Okay, and it takes some bit of time to observe this. Okay, so what you can do is here. This was yesterday. I will. Okay, so what you do is, let's say this is your data.
But
Okay.
Sandeep, for linear is very straightforward, right? Y is equal to mx plus c. What you teach us, right? That's a linear.
Yeah. So let's say if your data, like what we did yesterday, if your data, instead of one column, you have multiple columns, x1, x2, x3, x4. These are multiple columns, right? And this is your label y. Okay, right? So you are trying to find out the value of y based on this data, correct? And you're given, let's say, say thousands of records. This is your number of instances, and these are number of features. Okay. So when we are doing machine learning, when we say data, our model is learning from data, we usually express it as the data has got columns, we call them characteristics, and this is each of them is a sample or observation or instance or experience. Okay, that for these attributes, the value of this is this. Like for example, car value. Okay, imagine that you are supposed to predict the value of a car. Okay, so like the price of a car, that becomes your label. Price of a car is your label. And one feature could be the model number. Other feature could be the model year. Let's say this is model year, and other feature could be brand. Okay, and other feature could be right, model year, brand, and other feature could be cylinder. How many
It can
cylinder it is,
be
right?
manual or automation.
Manual or automation, like that. Okay, so and we have to predict the price. Okay, now so and think of let's say right, let's say brand is a 0 or 1 value, right? High end brand or low end brand. Okay, if high end is 1, that means it's high end, low end is 0. Okay, or let me make it simpler. Okay. Okay. All-wheel drive or not. Okay, whether it's all-wheel drive or not. Okay. Now we have model year, all-wheel drive, number of cylinders, and this was what? What did you say, Ranbir? Um,
It's
Manual.
manual or auto.
Manual or auto. Okay.
Auto, yeah.
80. Okay. This is 0 or 1. This is 0 or 1. Number of cylinders is number and model year. Okay. Now we have to predict the price from this one. Okay. This is the data given to you. Okay. So what you will do usually is you will say y is equal to, okay, you will say weightage of the first parameter is W1, X1 plus W2, X2 plus W3, X3 plus W4, X4 plus W0. Okay. Now we are saying that predict the price. This is the price, and these are the things. Now we don't know the value of W1, W2, W3, W4 right now. We will know those features later. We have to find out those values of W that can predict the price best. And we are given historical data of various cars. From that, we will learn W1, W2, W3, W4. Correct? And we will just use what we built yesterday, that we will basically load that data and then predict the values. Okay. Should we do that? Yeah, we could do that actually. Okay. Now, with this, right, there'll be a loss function which will basically try to, we will compute the gradient of the loss, observe which of the weight is bringing the loss down and up. We basically tweak the W1, W2, W3. So initial step will be just assume some random values for these weights. Okay. So yeah. So initial assumption will be that, and then we basically keep on tweaking these weights over and over again until our price starts to match the actual prices. Okay, so this is clear, right? Up to here, I think this is clear to all. What we did yesterday has got a practical application. Do you want to try to use it? Yes, what we built yesterday in the real data set?
So Sandeep, I think this is our mathematical equation, right? Just to calculate y is equal to W1 X1 plus so and so on, right?
This is called linear regression.
Linear regression. Okay.
Yeah.
So that's how we can calculate at any number of points, right? Up to xn.
Yes. These are columns. These are columns.
Yeah, these are columns, and W1, W2 would be your this row type.
No. W1, W2 is the model that we have to figure out. What we will do is we will assume some values of W1, predict the price based on the first, let's say this is Y1, Y2, Y3. We will predict using this, okay, and compute the loss based on the whole data. Okay. Y1 minus predicted Y, Y2 minus predicted Y, Y3 minus predicted Y, we square it and sum all of that error and then compute, is the error going up or down when we are increasing W1, W2, slightly increase W1, observe, is the error going up or down? And that's okay. Let's just take a look at, is that a good idea? Should I try to do yesterday's thing on this car prediction? What do you say?
I think we should do. So.
Okay.
I tried it with multiple things, but I failed. I got stuck.
Okay, show me.
Like this only.
Okay. Let's do that. Okay. And yes, what we did yesterday was actually good thing, very good thing, and it's fairly generalizable. Whatever we did, and we will discover the errors in it. Okay. So I want to prove that it's this thing not only works with what data we composed, it can work with the real data set. Okay, let's copy our model. Okay,
I'm not able to share since you are sharing.
okay, go ahead.
Visible? Is it visible?
Yeah.
Yeah. So I took 10 rows and 4 columns.
Oh, and you generated X. Okay.
Yeah, generated the X.
Okay.
And I just tested it with this.
And why? What happened to
Why
it?
I will show you. This is where
Okay,
I'm
okay, you generated data. Okay.
So why I'm generating with the like
Yeah, got it. Okay.
and yes. Then I'm creating the loss function with XYW. It's so here I'll show you. I'll just run it and show you. Okay. That's model. It's W. Some problem with this.
Okay.
I lost the track actually.
Okay.
No. This is something yours code. Sorry, I was looking at different one. Sorry. This that is why I lost that. Okay, this is what I called it actually. This is the method to this is the model, and I'm generating the data. I kept a random seed. I took some W and Excel show you. This is the actual W that I got. And this is the actual X and actual Y. This is the data that I've generated.
Okay.
Okay. And
Okay.
last function. And here what I'm doing is I'm just
Yeah, generating the W's. Yeah.
yeah. So initial W, so this is my guess, initial guess of W. And I tried to create the new value for X by appending 1 here and W transpose as this.
Okay.
Then, so when my W transpose is this one, I'm getting the predicted value like this. Okay,
Okay.
it's a row. And my loss function is like this.
Okay.
But when I so now I'm incrementing that and I'm trying to compute the gradient with this. So this is my initial loss. I'll get the initial loss. I'll just show you this thing. So what I have printed here is the initial loss, XYW, then initial loss. So this is my, God. So this is my X whole thing. This one is X. This one is Y. Y I have just reshaped it so that it looks like a column. And this is my Y and this is my W. W means the initial guess of W. And this is my new X. After this. When my like W transpose becomes like this, I just no, fill diagonal will do, right?
Yeah. Each row is, yeah, okay.
I got this. Then my this thing is not working. This compute gradient, after that it is not working.
No, why?
Because what happens is Y minus Y pred is not happening correctly. It is saying
Yeah. So why you also have to reshape like that?
Y has to be reshaped to Y I have reshaped like this actually. Initial Y, right? Initial Y is in column wise like this. This is my Y.
Yes.
But my Y pred is like I have 5 rows and where is that?
Take a look at what we did yesterday.
This
I think
is the
that's where I also had a confusion. Okay, this one is.
I'll get 5 rows and 5 columns here.
So from
what
each
to
of
do with
these,
that?
yeah, from each of these, the same value need to be subtracted, right? For each weight, right? 321, right? This. Now go up. Let's take a look at the Y basic one.
Y is this.
Okay. No, this looks very strange. It should be tiny change. Not this change.
156 or something will be the change, like 226 minus here it is 300 something, right?
Yeah, still too much.
Initial guess, right? It is so.
No. I mean, yeah, correct. So it's the initial guess. So from each of these, the value has to be subtracted. So it's coming out to be okay. Because if you see 96.8, 96.8, 96.8, so it's coming out to be, oh, no. But why is this so much different?
For each Y, I have 1 row here. Got my problem.
Yeah. So basically, from all of these values, same Y have to be subtracted.
Same Y has to be subtracted from this all Y and
all of the Y's, right? So if 2016 is there, so yeah, you are subtracting that. I can see it. You are subtracting it correctly. You can see minus 96 point that.
I'm trying to subtract like Y minus Y pred. So I should do like Y pred minus Y.
Show me the weights. I think there is something wrong with the weights. Okay. Yeah. So this row times this. Okay, show me the weight.
Loss function I'll have to show, right?
No. Scroll down. Yeah. So that one. Print WT. Yeah. Okay. Somebody was saying something?
No. I am trying to different. Okay, initial
so we'll
loss.
take the row, multiply it. No, you have to
loss function I'll show. Loss function. In the loss function, I'm trying to my Y is in a column model.
Yeah, this is correct.
Tried to
this is correct. Okay. Okay, debug it step by the way you're doing right now. Debug it that way. Slowly, just do slowly. Your approach is all perfect. All you need to do is put a little more time. That's all. You're there. Okay.
So
right.
I want to add something.
Yes.
Maybe I didn't make you clear it. So there are lots of things I'm printing. So.
Yeah, go ahead, Aman.
Yes, sir. Sir, actually the code in which you shared yesterday, the W is in 1D array. So we have to change it into 2D array. I was also
2D array,
the same problem.
Yeah.
Yes, sir.
Yeah.
So in the generate data function, the first function which we.
Yeah. So here, okay, the second functions that I wrote, like model,
generate data,
loss. Generate data, there was a problem, correct.
Yes,
so the W's were not really correctly generated. Sorry, the Y was not correctly generated.
So the W was coming out to into a 1D array. So if we here add W equals to NP dot array and we put the other thing into bracket, then it will convert into a 2D array. Then the code will run properly.
Okay. Okay. Yeah. The initial loss, like the first loss when we are doing here, do you mean to say
No, sir, not here. In the first function, only the generate data, which you just showed me earlier.
See, let's say we forget about generate data for a moment. Okay.
Yes.
So model is taking the X, adding 1 to it. Okay. And then doing this. Okay. That's giving the value of Y. Loss function first calls this data, this model to do the calculate the predicted Y, right? What we are trying to do first, we want to observe that if we just change one W at a time, how much is the loss? Like how much is the error going to be? So we wrote a function called loss given X and W and actual data set, it computes the overall error. Then we basically define the method to create, like if you have, let's say 20 Ws, it will create 20 arrays of Ws where each array would have only one W incremented. Okay. Then what we did a compute gradient. What we did here, first we compute the initial loss, then increase one W at a time, and then we calculate new losses based on these Ws, and then we compute the rate of change of loss with respect to each increment. And that's what we call gradient. And once we computed that, we did this. So here, the thing that you have to note is this, that when we are calculating predicted value here, okay? Yeah, so this W, okay, always has to be an array of arrays, okay? It cannot be a single value. It has to be 2D array. W has to be 2D array. That's why here, you see, we have put one more bracket. Oh, I think I got it. Can you just show me again where you're calculating W? Veena, can you show me the Ws? Go up. Just there's a place where you have printed the W, the first Ws before. Yeah, that one. There. Initial W, that one. Correct? And yeah, just put one more bracket there. That's all. Okay, come down, I'll tell you. Loss function, where is the loss function? When before passing to the loss function, just introduce one more this. Okay. The W, initial W that you're passing, just add one more bracket to it. Not here. When you are generating the data, when you're generating the data. np.random, and you are saying generate these W's like this. You can say w.reshape. Okay, w.reshape. Okay, just insert one new cell. Just I'll show you. Yeah. Insert one new cell. Yeah. Show me W and press shift enter. Shift enter. Go up. Yeah, here. So just say w.reshape. W.reshape. Reshape. Bracket. Mine 1, -1. Okay. Right. So now see, it has put one more bracket. So we are saying first dimension should be 1, and rest should be in the second value. Okay, now you do this. This will work. Good. So W equals, do that. W equals reshape. Yeah, this should work. Don't generate data, then let it be that way. Everything is all good. Yeah, let it be like this. Now go ahead. The data is already generated, so you don't have to worry. Correct? It's generated, right, already? Okay, sorry. Come down. I'll tell you. So data, let the data be generated. Come down. Let the data be there. Okay. Here, this is where I'm talking about. So when you are initially generating W's, reshape that W here. Got it? Yes. Before sending it to loss function, just reshape this. Yeah, just say reshape there dot after that random int dot reshape. Yeah. Yes. Now test it out. Someone was right. Basically, that W was the issue. Okay. Yeah. So is the loss increasing or going down? What's happening? Okay. Oh, you are just doing the compute gradient. Now let's move ahead. Okay. Let's move ahead. Okay. Control 0.
Veena, you are on mute if you're saying something.
Veena has left me to be her speaker. Okay.
Okay. Sorry, I think I was speaking. This, I have to do this, right? New weights. Yeah.
Yeah. Now run that, just run it.
This is your code.
Okay. Okay.
And here.
Okay. So run new weights, W equals new weights.
Why?
Okay. This is not defined.
Just wait.
Okay. Okay. Okay, copy that cell again and paste it. Let's see what happens. Yeah, copy the cell and paste it down. Let's see. Okay. Is the loss going down?
Loss is minus 96. Yeah. Minus 47. Yes, it is going down.
Okay.
Yes.
Okay, good. So run it like do 3 more times and you will reach there. Just run it. Yeah. Okay.
Yeah. From 40 to 17.
Okay. All right. So looks okay to me. Keep experimenting on
Yeah,
this.
I'll just do and I'll.
Yeah. And yeah. So yeah, wonderful. Wonderful. Awesome. Okay. Great. Great. So one simple dimension mismatch. And I think I made this mistake yesterday, right? And yeah, it took me a while to just handle that. Okay. Perfect. Super proud. Super proud. All right. All right. So this is the code that we wrote. Okay. And I'm going to just create a full library out of it. Okay. And yes, I would want everybody to, do this, right? Okay. So let's just copy paste this code here.
You're not sharing.
Oh, I'm not sharing. Sorry. Okay. I'm just going to create full library out of it. Okay. And then let's see if we can use this for, let's say, a car price prediction. Good idea? Okay. Let's see if we can use it for car price prediction. Okay. We will call this class as, okay. We'll call this, class as class my model. Okay. And it has these functions. Okay. This function I am okay to show to people. Okay. We call it predict. Okay. And there is an internal value in it called, right? This is called self, right? What do you call this? Constructor, right? Okay. I'm going to call it self.weights. Okay. Self.weights. And I don't know right now how many are going to be there, but there'll be something. So predict. Okay. The loss function again is something that, it's going to be internal. Okay. I'll call it my regression model. Okay. And yeah, people can set we'll call it uh, squared error. Okay. Mean squared error, MSE. Okay. That's our function. Okay. This is our loss function. We can also keep it separate. Okay. Let's call this thing outside and we will just say class or wait, let's say we can also put it in a separate file or something. Okay. This is called MSC. Okay. And here we can say define. Okay. We can say self dot, what was the name of the function? Okay. Okay. Let's just. Okay. So what we are doing is you can specify your own loss function. If you are not specifying loss function, we'll assume to be mean squared error. Okay. And you can specify your epsilon or let's say eta. Okay. Eta. By default, the value is going to be 0.01, right? That's your learning rate. Okay. So when you call my regression model, we are going to basically just have initialize the model, and right now it doesn't have the weights. They are set to none. When we do the model dot fit, we will initialize the weights. Okay. Everybody okay so far?
Eta needs to be set, right? Self that we don't.
Which
We are
one?
not using eta needs to be set, right?
Correct. So we are going to say self dot eta equals eta. Okay. So we are just consolidating everything into one single function class, and so that we can, the code becomes much more manageable. Okay. This is an internal function, so we are going to hide it. So we are keeping it hidden. Okay. And okay, we will make this thing called call. Okay. And say define predict. Okay, predict, and people will call it with X. Okay, and what we will do is we will return. Okay, when people call it with X, first we will add shape to it. Okay, all right, we will find out, we'll add one to this one, and then okay, I'll call it a method called internal method call, and it would basically, okay, just do this. Okay. Good. So what we are doing, we are hiding lots of functions, and basically these functions are internal functions. Okay, like this one is an internal function, so we are saying self dot. Good. Instead of this way, we'll just set this. Okay, that should be good enough, because this does, and we should say self here. Okay, we should self here, so we are good. And yeah, this is a static function, so we can call it like just like this. And yeah, this is good enough. Okay.
So in Python, it's like when you give this underscore, it is like a private method.
It's kind of a convention. It's not something that it kind of deal with it. Okay, so it's just a convention. It's just a convention for ourselves that we are going to just use them internally. Okay. All right. We'll call it internally. Okay. Now, when somebody calls a method called fit, okay, what we are going to do is we are giving X and Y. Okay. Somebody calls a method called fit. What are we going to do? We are going to say, right? And okay, epochs equal to 20. And right, so when somebody calls this method called fit, and by default, we are just putting some number of epochs to it. Okay, so what we are going to do right now is, first and foremost, we are going to add one to this data. Okay, so that yeah, it is essentially just we want to do it once. Okay, so we are adding one to this once only. Okay, then what we are doing, we are saying here, okay, so we are fitting this, and okay, where is the weight initialization? We are not initializing weights, correct? Okay. Okay. So, okay. All right. All right. Increment weight. Where is the weight initialization part? We did not have that in this logic. Oh, we basically, what we did yesterday was we just created this way. Okay, so we'll define a routine called initialize weights. Okay, initialize weights, and it takes it takes the number of features n, and what it does is it sets self dot weights equal to what is that method? np.random, right? We have done that yesterday, correct? Okay, something like this. Okay, so right now we are just going to say random int, not random int. Instead, we are going to, yeah, let's just say that this is our strategy. Okay, we are just generating this, and then we are reshaping it such that these weights are 1 and all of them are in this. Okay, so these are our weights. Cool. So we have initialized the weights. Okay, and this is let me go back here. So what we want to do is we want to say, okay, self dot init, and this is okay. Yes, so I think this is better. So we initialize the weights, okay? We added 1 to it, okay? We added 1 to it. So we added 1 to x. We initialize the weights. Now is the next step. What we do is we'll say for epoch in, for let's say I in range epoch, okay, and at every step what we are going to do is we are going to say self dot weights equals to new underscore weights and x1 y and w. Okay, sorry, x1 y and self dot weights. Okay, so here let's just start from here. Okay, somebody gives us x, somebody gives us y, and says learn from this data. Okay, and we are saying run it for 20 epochs. Okay. Okay. We can also do one smart thing. We can say if self dot weights equals none. Okay. So if the weights are not initialized, only then those weights will be reinitialized. Should we do this? No. I'm just thinking louder. Should we do this way?
It is not required, right? We are not calling the fit again and again. So
What if we want to call the fit again and again? Okay, we'll just do it again then in that case. Okay, I mean, I'm unnecessarily over optimizing. Okay, so we go slowly. We are saying, here is my data. This is the features and the data of cars, and these are the prices of the cars, and learn from it and run it for, say, by default 20 epochs. Okay, now what we are doing, finding how many rows are there in the data, that's called M. How many columns are there, meaning features are there in the data, so that is N. And then we are saying insert 1 to X So we inserted 1 to x, and then we initialize the weights. How many weights do we want to initialize? We want to basically initialize the weights between, let's say, okay, I think instead of this, should I do this? Okay, I don't like this method. We'll just say np.random.random 4. Oh, we just forgot the initializing, importing the NumPy. That's the only thing we needed. Okay, so we'll just use this way. Okay, we'll just say random.random instead of worrying too much about it. Okay. Oh, why can't we do this one? Yeah, this is better, right? Yeah, this is better. So we'll just initialize it like this. Okay, we are saying 1 rows and n plus 1 columns. Okay, that's it. So we initialize the weights. Okay, we initialize the weights.
Reshape. Reshape is not required. In this way, it will be 2-dimensional.
Yeah. So you see that there are 2 brackets. Okay, so we are saying m is this, n is this. We inserted 1 to n, so our data became this. Okay, and yeah, so basically we are not changing x, we are creating new x value by adding 1 more value. Okay, now we are saying self.init weights. Okay, these many weights it will initialize and other features. And what we're doing is for range in epochs, self.weights equals to new weights, and this is basically the update weights. Okay, we should just call it update weights. Okay, update weights. Okay, and what it does is it doesn't need to basically take w from us. Okay, self dot weights. Okay, self dot weights. Okay, now what it does is it calls a method called compute gradient, and it basically gets the gradients from this one, and that's what it is going to do. Okay, so
in the fit you should have x, right?
Okay.
In the fit method, last line, we are calling it as x1. Last line, for loop in the for loop. New weights of x1 should be x.
Yeah, it should be x. Correct. One thing I'm thinking that all these methods, right? These methods, can I just put it in another class? We'll just call it my, gradient utils. Okay, we'll just call it this way so that the 2 things are separate. Let's say this one is a general function. Okay, not only used here, but used everywhere else. Okay, and yeah, so here we are saying gradient utils dot MSC. This is better, right? Okay, so we basically just doing something like this. Okay, and I think this could be good enough. Okay, predict should be part of this, that I agree. Okay, call should be part of this one internally. Okay, we have to basically just change this, and we are going to say self dot weights dot t, and that's it. Okay, and yeah, this is okay. Self dot weights, yes. So call has to be part of it. Initialize weight, again, this can also be part of some other strategy. Like there are hundreds of strategies to initialize the weights, and you will be surprised that it might look very rudimentary to you that, oh, we are just generating random numbers for weights, but the entire neural network research got accelerated because of one strategy of initializing weights. Okay, sounds crazy, right? This part, okay? Just this part actually changed the way the neural network are looked upon. Okay, so one paper got published on how to initialize weights so that gradient descent works better. Okay, and this strategy which I'm doing here was basically replaced by a new strategy that we'll study in part of the course, and that did a breakthrough. Okay, now, okay, this is something that we are, what do you say, incrementing W's, okay? And should we just move it again to the utils? Compute gradient. Yes, these two methods I'm moving to my gradient utils, okay? I'm calling it, okay? Increase W's, and that's it, okay? So what it does is it finds those manys, computes the diagonal, increases the values of diagonal, and then it or why not just prepare this, because this is again and again being prepared, correct? This is again and again being prepared. So we could just call it like a prepare, okay? It basically will give us prepare deltas, no? Prepare delta. So it'll keep the deltas filled and we'll give it W and we'll just add, okay? It will right now return this W once, okay? And, okay, where is that thing? What's the name of that function? Okay.
Compute grade.
Compute gradients, right? So, okay. Okay, we'll just call them deltas, okay? And we basically just do this, a bit of optimization. I hope you guys will forgive me for this. And yes, that's it. Okay, so we have the deltas, okay? We will pass the deltas, okay? We'll pass the deltas and yeah, if this is not available, okay, it'll basically be prepared, okay, with this. Okay, we'll calculate this one, and that's about it. Okay, so increase deltas is essentially deltas plus W. Perfect. Because these are going to remain same, right, across this, and we'll basically just pass it over and over. Okay, so compute gradient takes X, Y, W, okay, and okay, X, Y, W, and then right, okay, and it returns the gradients, okay, and we have something like update, okay, compute gradients, and then new gradients, okay, new gradients. We can just separate this logic. So we are just cleaning it up so that we are clear about it, okay. Okay, we are saying new weights, okay, and here we are saying for this data, it is calling right, X, Y. We can also pass the deltas as we want them to be here, Okay. Okay. So this is a gradient step. So it takes X, Y, W, and it also takes eta. Okay. And we'll call it like this. And right. And if this is none, what it does is it basically, okay, I'm having my, okay, I'm just trying to over optimize this. Okay, so X, Y, W, eta, deltas, okay, and if deltas equals none, what it does is it calls prepare deltas and okay, prepare deltas for W, and then it uses those deltas, it computes the gradients and returns the new W's. Perfect. Okay, now. Okay, perfect. Okay. Okay. That's the name of the function.
It's grad utils, right?
Now what?
The name of the method, grad utils dot. You were calling it as util start.
Okay, let me see what I'm trying to do.
No, that
Okay,
code is removed. So,
this one, yeah. So utils. Okay, so here, basically, this guy is going to take new weights. Okay. Okay, it takes X and Y, and then it takes self.weights. Okay, and then self.weights, then it passes the eta, whatever we are passing here. We have the self.eta, no? We have the self.eta. Okay, we'll pass self.eta. Okay, and we will also just prepare what was the deltas. Deltas equals, okay, grad utils dot, what was the name of the function again? Prepare deltas. Okay, so it takes those many prepare deltas, yes. Looks okay to me now, but the moment I run it.
W should be self.weights. Deltas, prepare deltas.
Okay.
Line number 52.
When and these are, I'm putting the one to it, then I'm initializing the weights. Okay, then I'm calculating the, this will be okay, and then I'm saying do it for this. I'm calling gradient utils with X, Y, weights and eta. X, Y, weights and eta. Let's see, is that what we had here? X, Y, oh, weights and eta and deltas. And deltas, right? Okay. Basically, this deltas, preparing the diagonal matrix of deltas, it is better to just keep it, prepare once and use it over and over. Okay. Right. rather than again and again doing this whole exercise of doing this exercise of filling the diagonal, first create those many like that big array, fill it with deltas. We'll just retain it in the memory so that you don't have to do it over and over again. Okay, because this can be quickly utilized again. Okay, looks okay, is it? No? Okay. All right. All right. This one doesn't have the self to it. Okay, so we have to pass the self here. Okay, and you have to call it like self. Okay, and call. There are many mistakes in this. Okay, so new weights. Let's take a look at new weights. It takes x, y, w. This. If deltas is not provided, it'll basically prepare delta for you. It'll be a little bit penalizing, but that's okay. Okay, now we are saying eta equals to, this is not required. Okay, we are saying, gradient equals, also we can just remove this line. Okay, and right, we are saying gradient, compute gradient, and then we are just saying x, y, w delta. So it will compute the gradient and multiply those gradients with this, and then return this. Okay, cool. And those are the new gradients it will return. And it will call the compute gradient. It takes x, y, g. It computes the initial loss. Now this loss function we have changed, right? We can say gradient utils, or you can just say MSC. Okay. And here again, we can, okay, forget about this loss. I'm just removing this loss from here. Okay. Okay, let it be like this. So internally, it's just right now using the loss function that we have mentioned. Okay, and yes. Okay, so whatever we want to use this as a loss function. Okay, and we can just say MSC here right now. Okay, or you can, if you want, you can just further be make it configurable. That okay, I'm saying whatever loss function I'm saying, just pass it inside, and then here you can say further, you can say grad utils dot MSC. Okay, yeah, that should be good enough. Perfect. So let's go back again. Okay, or should I just run it and see how bad does it look like? Okay, this is my regression model. Okay. Okay, here do we want to specify eta or let it be? Okay, let it be. So this is my regression model, and I'm saying whatever data we generated earlier, where is that data? Okay. I'm just generating the data. Okay. And
can you make it as two-dimensional? N is equal to 1 here. We need multiple features. Generative.
We'll do that. We'll do that soon. Okay, we'll do that soon. I just want to see, there are lots and lots of error that are going to be there. Okay, it says model not defined. Where is that model? Oh, this one is the model. Okay, we can just simply say this. Okay, so you can see x dot shape and y dot shape. Okay, yes. Now I'm going to use this regression model that we prepared, reg dot, what is that? Reg dot fit. Okay, we'll say reg dot fit. Okay. Okay. All right. This has no such thing called shape. Okay, slowly go up and see what's happening. Okay, I have to pass the self method. Okay, so in a single shot, it turns out to be okay. Now it is throwing compute grade is not defined. Where it is not defined? Here, right? Compute gradient not defined. Okay.
So why we have to call the same, if it's in the same class, right? So why we have to call with the class name? That grad utils.
I think you have to mention it like this. I don't know why. Okay, let me see. I think it's not required, but again, where is that medal? It's saying that. Okay, let's just fix those syntax errors. Okay, right now it is telling me model is not defined. Okay, so grad utils is telling me that MSC, okay, is this. Okay. All right, all right, all right. So we have a mean squared error like this, okay? And yes, okay.
So 3 we are calling model x comma w. That model is not there. Line of
Yes. So I think this is a mistake on our part. Okay. So what we should do is when we are calculating the loss, right? Okay, when we are saying compute gradient, we need to basically pass the y predicted. Okay, so okay, and we can basically just pass our model here. Okay, we'll just pass our model here. Okay, and this model will further pass it here. Okay. Okay, we'll just pass the model here. This makes sense. So first, ideally, this is a wrong way to do it. Okay. Ideally, what we should do is we should just say y predicted here. Okay. And we should do here. Okay. We should do, this is my y predicted. Y predicted. Okay. And right. So this is the right model dot call. Okay, and it's going to basically call my models method and then do the ask that to just multiply x and y, x and w to produce the y predicted, and here it would just pass it here. This is better way of doing it. You see that? This is better way to doing it. So first we are asking model to give me a predicted value, and then it is going to just increase the W's and again call the model for the new values. Okay. Okay. Yeah. Yeah. So this is little skewed. Okay. Little skewed. And again, we have to do the same thing here. We have to do the same thing here. Okay. This is Y predicted. Okay. So we computed the initial loss. Now we are asking it to compute this. Okay. All right. This should be okay, right? Okay. The difference between predict and call is that predict is adding one to it, and call is not. Okay. Call is assuming that X contains the value. Okay. X contains the value. All right. So that's all. I think this is correct. This should be okay. Okay. Let's try again. Okay. Compute gradient is missing one positional argument called that. Okay. Where are we seeing this? Here, right? New weights. It's missing the loss function. What? Okay. Help me out, everyone. So compute gradient. So this one basically gives us new weights, and this is the main function we are passing. And this one should be, we should pass the model here, and here we are going to pass, you see, here we are going to pass this step, we are just going to pass ourself. Okay, so that's it. So we're passing the model, and let's see where it says predicted is not defined. Okay, Y predicted should be here. Okay. Okay. Operands could not broadcast together. Okay. All right. All right. So here we are. Now, this Y, when we say model.fit, okay. So the Y need to be, let's take a look at X and Y. X and Y. Okay. So this Y need to be reshaped. Okay. This need to be reshaped. So we are going to reshape the Y. Okay. So H, we have added 1 to H. Okay. And now what we're going to do is we're going to say Y is equal to Y dot reshape and 1. We want the last dimension to have one value, and that's about it. Okay. All right. Delta could not be defined. Okay. Gradient, oh, delta. All right. Okay. Where is my delta? Okay. Prepare deltas. Okay. I would just, keep this delta somewhere. Okay, where is the prepare delta functions? Who is calling these? Okay, this, right? And just pass here. How much was the value we kept?
1e minus 2.
1e minus, yeah. So we'll just call this delta, just define the delta here. Okay, I can't make it much cleaner the way these guys have done. Okay, probably I'll do it some other time. Yeah, I probably need much more. Delta is not again defined. Let's see what happened to the delta. Okay, so delta would be needed in this one, correct? We have to, pass the deltas. Okay, and we have to pass the, I'll just pass the delta also. Okay. All right. Okay. We will learn how to do this better. Okay. Missing the thing called, where is this? Okay. Okay. Oh, now it's going somewhere, correct? Now let's see if we can, in here, we can print the loss as well. Okay, so this is the new loss, and we can, every time what we can do is we can just call this loss function. Okay, and okay, and here, so shall we print it separately or let it be like this? Okay, initial loss and new loss, and these are the gradients. And after updating the gradients, we should print the loss, correct? We should print before and after, or should I print it before? Okay, let's print it just after these. Okay, so just after we have done this, we can print the loss. Okay, we will just do this. Okay, we'll just do this on every loop. Okay, this is where we have updated. Okay, so we are saying, right, self.call. Okay, where is my method? Yes, self.call. Okay, and we are saying this is my X and these are my weights. And this is my loss. Okay, so I'm printing loss and I'm printing W's, and that should be it. Okay. Okay. What was the loss function name, everybody? Loss function name is grad. Okay. W is not defined. It should be self-weights. Okay. Where? Oh, here. But why do we need weights in this MSE? Why do we need weights? We don't need weights in the MSE. Okay. Looks like loss is going down. You can see the loss going down. Okay. 14, 17, 25, 26. Doesn't look great. What are these? Okay. Shouldn't there be 3x? Why there are 4? 1, 2, 3, 4. Oh, I get it. I get it. I get it. What's happening is, okay, where did I mess up, everybody? So we took the number of instances, we took the number of features. We created ones, added ones to X. Okay. Then we said initialize weights. Okay. And why did it initialized? So n will be how much for x dot shape? Okay. 3. What? X and y? 3. How come? Oh, it has already added 1 to it. Okay. It should not be adding 1 to it. That's the problem. Okay. Okay. Yes.
Next one then. Right?
Now it makes sense.
There it should be returning x1. You are returning x.
Yes, yes. See, I'm generating data. I'm generating data. This data that I'm returning should not have that extra 1. Okay. I don't want to return because my data, because there are 2x, right? One is having that extra 1 that is for my internal usage, because I want, when I'm multiplying W, instead of eliminating W's one column and all of that, to make it simpler, I'm just adding 1 to it. That's for faster calculation. Okay. But X does not have more X has only 2 features here. Okay. X has, where is the X? Right? The X ideally here is going to have only 2 features. I'm telling that only create data with 2 columns and 10 rows. Okay. That's all I'm doing. So I can as well say that, okay, generate this with, say, 4 columns. Okay. It'll generate this with 4 columns. Okay. And then I can do the model.fit. Okay. I can also say here epoch equals 100. Okay. So it'll basically just start from here, go on to this, then, this is going well, right? So it is dropping, 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 and it is becoming saturated, right? At 284, no, it did not become saturated. So we increase once more, and okay. Now, you see, after here, it has become saturated, okay? And it has figured out these weights. Okay, these are the weights that it has figured out. Let's go up and see what were the actual weights. Okay, the actual weights were 19, 135, 25, 74, 123. Make sense, everybody? Yeah, no?
Yes, sir.
Yes.
Okay, I'll just remove from here and I'll put it here. Okay, this is how my model looks like. Okay, first I called my model, I gave it X and Y, it learned from it. Okay, it learned from it. Now I can say rag. Okay, let's say this is my X0 and Y0. Okay, let's say this is X0 and Y0. Okay, now let's take a look if it can predict the same value for me. Right, this is my model, and I'm saying reg dot predict. Okay, X0, and I'll just do the just put one more bracket inside it. Okay, or we can say give me the 0th one. Okay, and all columns, right? That's another way of saying to retain the shape. Okay, you see, 0th column, go from 0. Yeah, this is better, right? So for 0th column, I'm calling the model just to observe how it, oh, it did not predict. Why? I did not return. Oh man, don't tell me I have to forgot to do this. Oh man. Okay, now, okay, so it says that predicted value is 224.89135. Okay, let's now take a look at the first 5 records from it. Okay, so okay, those who are confused about this, right? So X is a NumPy array. Okay, this is my NumPy array. This is my data. Okay, and so is Y. Okay, so is Y. I can access, let's say, first 5 rows from it. Okay, like this. We can say, just give me first 5 rows. And if I want to say, give me first 5 rows and first 2 columns, I can say this. Okay, so it gave me those many rows, those many columns. Okay, if I want to say, give me all the rows starting, give me all the rows, give me all the rows starting at 2 up to 4, and right, and all columns. So it has given me all the rows starting at 2, going up to but not including 4. Make sense, everyone? So this is NumPy array. NumPy array provides you slicing across columns and rows in every dimension. Everybody okay with this? No?
Yes, sir.
Veena and Rahul?
Yes.
Okay. So basically, NumPy provides you to do all of the slicing and dicing of the data in every dimension. Like this. Okay. So let's just test out whether our model is working well or not. So we tested on 0th row. We picked the first record and validated our model. Now let's say this, I'm going to pick first 5 rows. These are first 5 rows. And from Y, I'm going to pick first 5 columns. Okay. Now, let's say I'm calling the model. I'm saying predict the value for first 5 rows, right? As per the model, the answer is 224, while the actual was 226. 213, 213, 214, 213, 307, 307, 242, 241. So we are very close, correct? So our model is performing really good. So once we have trained the model, when we said rag.fit, first we created our model instance of it. We said rag.fit, it learned from the data and prepared internally something called weights. Okay. Now, once it has learned it, then we are saying rag.predict on the other data or any data. And it's basically giving us the predictions. Okay. Am I making sense, everyone? No?
Yes.
Yes.
Okay. So I've basically just coded everything. Okay. So now we can ScikitLearn regression data set. Okay. Okay. So there are these data sets. Okay. Something okay. What should I do here? Okay. Car price data set. Okay. We can basically, so it has all these columns and rows. Okay. So test and train. Okay. It's a pretty small data set. Okay. We're going to download both of these data sets. Okay. I am downloading train.csv. Don't tell me, it'll basically just keep on asking all kinds of questions about the data set. Car prices data set. Where is that column? Yeah. So it is only test data set and train data set. This one is 2.2 megabytes. Okay. Now, all right, this is my training data set. Okay. And then where is the test data set? I'll also download the test data set. Okay. Now let's upload it into the lab, everyone. So we are uploading the data set that we just downloaded here. Okay. All right. Okay. Now, since our data is in CSV format, this is my data. Okay. How do I operate upon this data? Okay. This is where something called pandas come into play. Okay. I can close this, right? This is not required anymore. Okay. I'm just closing this. I'll just focus here. So right now we have built our model and the code. And now I want to do is, this is my data set. Okay. How to deal with it? This is where a library called pandas come into play. Import pandas as PD. Okay, everybody okay so far? So I imported pandas. Pandas is a library that lets you handle all kinds of formats. You can interact with databases, you can interact with CSV files, you can deal with all kinds of things. Okay, when you want to handle the data in the form of tables. So NumPy is great with numbers. Okay, NumPy is good with numbers. But if your data is like strings, column, and so on, first you start with pandas. Okay, so pandas, we are saying there is something called, these are the various functions. You can load the data from HTML, you can load the data from JSON, you can load the data from CSV. Okay, let's say I'm loading the data from CSV. Okay, and here I'm saying train.csv. Okay, this is my, okay, so it loaded this particular file into this data frame, I can take a look at this. Okay, so you can see this is my data, right? This is my data. It has got ID, price, levy, manufacturer, model, year, category, leather interior, injure volume. Okay, what else is there? There is cylinders. Okay, there is gear type, there are airbags, and so on. Okay, so you see this. So there are lots of different kind of features. Okay, so what we are going to do is, so this is our data frame. Okay, this is our data frame. Okay, now everybody okay with this?
Yes.
Right? So it's a good exercise what we are doing. We are basically introducing you to pandas by the way of same problem statement. So now we want to apply our algorithm on the real world data set. So we got the data set from a website called Kaggle, where many people upload data set, and that's about it. So here now, let's say I want to extract a column called price. Okay, so I can say this, it gives me only the column called price. Okay, so this way I can select columns. Okay, and here, right, so you can say df.head, it gives us few rows from that data set. Okay, so let's just not look at any other data set. What is levy? Anybody acquainted with the cars? No? Okay. Now, what I'm interested in.
Tax levy.
Yeah, looks like that. Okay. So what I'm going to do is I'm going to just keep the y equals to df.price. Okay. That's taken. Now, from this df, I'm going to pick some columns. Okay. I'm going to say, okay, let's ignore that. Okay. Let's say product year. We'll just take product year. Okay, product year. Okay, this is the category right now. We are going to ignore that. Okay, and here it says leather interior, yes, no. Okay, we'll keep mileage as one of the columns. Mileage. Okay, everybody okay so far? Cylinders. Okay, cylinders, and let's say airbags. Okay, airbags. We'll talk about how to deal with the categories. Right now, we are only doing this. Good. Now, there's a slight bit of a problem here. This data contains a text. It's not a number, right? It's not a number. So what to do with this? Okay, so now here, here, what we can do is we can write some form of translator. Okay, we can write some form of translator using the data frame itself. Okay, using the data frame itself. And yes, okay, or let's just, do you want me to, yeah, well, one thing we can do is, how to eliminate KM from this. Okay, how to eliminate KM from this. Let's see. Okay, let's just pick only that column. Okay, let's just pick only that column. We'll just say, give me mileage. Okay, so it gave us mileage. Then we are saying, so there is a function called .str. Okay, there is a way to do it. Okay, and yes, let me think for a moment. Okay, and I'm pretty poor at it. Okay, so one way to do it is for mileage in mileage. Okay, print m. Okay. No, it's not. Okay, let me think for a moment. Okay. Okay. For m in mileage, print m. Yes, it's working this way. Okay. Now we got this, right? And we can, okay, we can split it, right? We can say m dot split, and we'll just pick 0 value and we'll cast it to integer. Okay, looks like it is working. Okay, and we'll just put it in the result. What do you say? Okay, this I'm going to put it in that result. So you can see here is that value. Now I can just add one more column. Okay, so this, okay, let's just call this, you know, I'm going to add one more column called my mileage. Okay, mileage int. Okay, and I'm going to just put it like this. Okay, let's see. It has added one more column. Okay, so what I did, I wanted to clean up this one, remove the km from it. So what I did, I picked the column value, went over the list, and then splitted it based on the white space, and then picked the 0 value, converted it into number, and then appended to this array result. And then I created a new column in the data frame. That's it. Okay. So what we learned is that we can, so data frame is like a database table. It has got columns and rows. Okay. NumPy array is numeric numbers, which can have rows, columns, and then the grid inside the columns and so on. So it can have infinite number of dimensions. In case of data frame, you have 2 dimensions, rows and columns. Okay. So, and you can select a column by providing the name of the column. Okay, you can load the data using, say, read CSV or any other function provided, or you can convert an existing array into the data frame. Okay, so here what we have done, we have picked a particular price column and put it into Y. Okay, and here we can actually, yeah, better would be like, if you do this way, there are 2 different ways. If you put, let's say, a list of columns, okay, if you provide a single column, it gives you something called a series. Okay, series is like an array. Okay, series is like an array. And right, if you provide double brackets inside, meaning you provide a list of columns, it gives you a data frame back. It basically gives you another data frame. Otherwise, it gives you something called a series. Okay, so we are going to put this value. Okay, and further, this you see this price, you can further, you can get the, I think, right, you can convert this into a NumPy array. Okay, so now Y is a NumPy array. See that? We converted a series into a NumPy array. Perfect. Everybody okay so far? So we picked the price column, put it in Y. So we parked it there. Now moving ahead, okay, moving ahead, we are interested in these kind of columns. We'll talk about that. Now, what we are going to do further is that we are going to introduce one more column to it. Okay, we are creating a new column by translating mileage. So we are writing kind of a custom logic. So we went over the entire, first we picked that column. And when we pick that column is called a series. Okay, it's like an array. Now we are going over that array or series and adding values to result. Now we got this result at the end of it. Okay, let's say here, this we have produced. Now we are creating another column called MIL int. That's about it. So in the data frame, now you can see the column called int, right? So we are going to now, we're going to just pick only these columns that are of our interest, okay? And here, we are only, instead of the mileage, we are only interested in these numbers, okay? So my df equals this. So this is a cleaner, smaller data frame, okay? This is going to be our x, okay? Now, right, is there a way to convert it into NumPy? np.array, will it work? It did work, yeah? So this is my capital X. Okay, so my y, x dot shape, y dot shape. Okay, so these many instances, these many columns, right? Now let's take a look at, okay, let's take a look at our, what was that model name? Let's pick that part. This is my model name. Okay. Okay. So here, all right. Okay. Now let's take a look at if this works or not. Okay. So initially the loss is really big, then the loss is increasing. The loss has gone further crazy. It is just going crazy. Okay. Now let's take a look at what actually is happening here. Okay. So we'll just try to reduce the okay. No, it's still exploding. No, there is something seriously wrong with my data and I need to understand it. Okay, so what's happening here is that it is just going crazy on this data set. Okay, it is just going crazy on this data set. And okay, I would, let's see if we can come up with some strategy to reduce these values. Okay, so production year, mileage, okay, cylinders, 6-cylinder, airbags, 1.2. All right, this looks okay to me. The data looks okay to me. And okay. The data looks okay to me. What's wrong with this data? So initially, it had just gone bonkers, isn't it? So the initial loss is way too high here, right? All right, but this is good. We are getting somewhere. Okay. All right. So today we got started with pandas. Okay. Slowly we are learning pandas. I hope everybody is okay so far. We will learn how to fix it. And if any one of you can fix this code, that'll be great. Okay. All right.
Sir, I tried the last class and I'm facing the same issue. Like it is going, the error is going infinite.
Okay. Let's try to figure out where I have messed up in the code. And I would want you guys to go through the code and let's try to see what we can do in order to fix it. Is it like, okay, did I make a mistake in Y? I think so. Okay, I'm going to do this. Y equals Y dot reshape minus 1 and 1. Okay, now, no, it's still going haywire. Okay, still going haywire. Okay, let's just debug it in the next discussion. So here there is a number overflow. So it's kind of, okay, where is my eta to be set? Can I set the eta here? Self eta equals this. Okay, I'm going to just put the eta to be 0.0001. Again, it went. No, it's just going wrong way. What? Okay, let's just put the debug statements in the code, in the code, the things that we coded earlier, and then observe where have we made mistakes. Okay. All right, it's a good exercise. So we are continuing with the same thread, and the same thread is that the gradient descent. We learned Python by that way. We learned NumPy using that, and now we are learning to do the data frame. Okay, and yeah, there's no logic in just studying pandas in an independent way. Okay, this is a better way of learning it. Okay, if you have the urge to go through all the functions of pandas, you can simply say, after importing the pandas, you can simply say pandas. Okay, and here say import pandas as PD. Okay, so you can say PD dot and press tab. It will show you all possible functions here. Okay, and you will see you can read HTML file, JSON file, and so on. Further, right, the data frame object that we created using CSV, you have all these functions. Okay, you can start going through them. Some of them are basically right, picking the column, picking the rows, and so on. Okay, so that's a better way of you can just go through these common functions and then okay. All right, so I think we will carry on from here, probably a little bit more structured way. We'll go through this was supposed to be how it is, people study it. We'll just go through this quickly once again in the next class. We have already talked about all of these things, and I think I've already talked about this. Have I talked about this in broadcast?
No, Sandeep, not yet. And Sandeep, are you sharing these deck also? So if required, we can also go through the same also,
It
you
is
know?
there. It is there in the course. It is there in the course. Okay.
Okay,
I'll check it. If it's not there, let me know. It should be there. Yeah. In
fair
all
enough.
the. Okay.
And
Now,
so Sandeep, Panda is only used for the data structure perspective, right? To just,
data.
you know, explore the data, you know, in a different format and all, and then whatever the function we want to be applied. That's only the purpose of Panda.
See, it's like this. First, you load the data using pandas, clean up, and then convert it into NumPy array, and then you feed it to your algorithm, train the model on it, and then start using the model.
Right.
So NumPy, so pandas, so your data from your file to pandas, then to the NumPy array, and then to the algorithm, and that's it.
Okay, fair enough.
Okay. So most of like what you do using SQL, like where clause, where this is equal to that, and so on, all of that is possible with the, I mean,
Panda.
all of that was with pandas, right?
Okay, so Panda is having all those in build library, which we can use as it is.
Yes, it's called PANDAS, pandas. Okay. And I used to call it panda in the beginning, but it's actually pandas. Okay. Yeah. Okay. So yeah, I don't know why there's a plural, but yeah, it is there. All right, let me just commit it before we exit today. And yes, I'll just commit the two files that we have added today. Okay. Okay. And right.
So then usually the data sets are in CSV mode, right? Or in Excel format.
In real world, the data sets are in database. Okay. In real world, it is there. Second, yeah, but mostly what people do is they export the data from database and put it in CSV. So yes, mostly you will get the data in CSV format. Sometimes in JSON format. Sometimes in some of the cases, people provide the data in Parquet format. Okay, there is something called Parquet format, which is really fast and really compressed format. Okay, that you can also load with pandas. Okay, Parquet, ORC, JSON, HTML, CSV, most of them. Okay, so yeah. It is an XML, all of that you can load with pandas. So yeah, the story starts with pandas and then it ends with your gradient descent. Okay. And yeah, so that's how it is. I have committed the code and perfect. I would request everybody to just work on this. Help me, whoever can debug this, figure out like why it's not working. Yeah, let me know. Okay, this is important. This is going to be quite interesting exercise. Observe where am I doing it wrong. If there is um, like, have I missed a column? Have I missed a row? Is it something to do with the data type or something? Just debug it, do the stepwise, and try to figure out where is the mistake. This is a common thing. The nan, the moment you see nan, you are seeing not a number, right? It is, I've seen it many times, like hundreds of times I've seen. Almost in every model, it kind of starts going out and then you basically bring it back. So in TensorFlow, everywhere, this is the same problem that you'll see. Okay, so yes, I hope this is useful to everybody. All right, so see you next week. In the meantime, go through the two notebooks that we have done in last 2 days, and this is extremely important for everybody. Even if you missed previous classes, help me debug this, okay? Help me debug this code and figure out how can you just solving. Okay, cool. So though we are learning Pandas, but we are also fixing our NumPy code and also fixing our gradient descent code. All right. Everybody have a good week ahead. Thank you.
Thank you, sir.
Thank you, sir.
Thank you.